Okay.
No.
So listen, hey, we're going to change the problem slightly. Hey, don't talk. Come on, you gotta focus. You gotta focus. We're going to change the problem slightly so I can illustrate this new concept. It will not preclude the fact that I can still show you the u substitution part. Okay. So we're going to put limits on this integral. We're going to go from 0 to 2. We are changing the problem from an antiderivative to an integral. Understand? Okay, prior to today, if you had been given an assignment where this was on the paper, the expectation would be that it would be calculated aloud. You pick up your calculator, type it in. Okay? We are now practicing the non-calculator portion of the AP test, however, so we have to learn how to do this without a calculator. Turns out to be really, really simple. Think of the fundamental theorem of calculus. When I talk about the fundamental theorem, I often talk about integrating velocity. Raise your hand if you can tell me another symbol for v of t. Really simple one. I'll pay everybody. What's another really simple symbol for v of t? Danny? Close. We use x prime, since x represents position. So that's another symbol for velocity. How many knew it? 2 points. Okay, 3 for Danny.
Why are we using 0 and 2?
Random example.
Oh,
Yeah, good question. Just random examples. 2 points. What's that?
use anything?
Yes. Yeah, anything you want.
Wait, why is it not like that?
So if we're talking about a moving particle, we use x to represent the position of the particle. Therefore, the derivative of x is the velocity. So that's why we're using that. Good question.
Now, integration, are we always talking about a moving particle?
No, in fact, I'll show you in a second. So here, think of a moving particle. Okay. When I perform this integral, let's just pretend, so it's easy to talk about, that the result is 8. Raise your hand and tell me, what does the result mean? What does it mean that this integral has a value of 8? You're remembering, we're reviewing last unit now. Now, just to make sure you know how important this is. The AP test is worth 108 points. Your understanding of the fundamental theorem is going to get you 30 of those points. So this is crucial, you know what this means. Got it?
Like the total distance traveled by the particle is 8?
2 points, but common error. So it's not the total distance traveled.
Isn't it the distance between where the particle started and where the particle ended?
Perfect. So distance between where the particle started, where it ended. Distance traveled could be much more. The particle could have gone way to the right and then come back to the left. 8 is how far apart my hands are. How many knew it? 2 points. Okay. 3 for Gil. What is the other way to compute the difference between where I started versus where I end up? There's another way. You got to know it. Like, what's the other formula for computing difference between where I started versus where I end up?
X of 2 minus x of 0.
Good. Raise your hand if you remember that. 2 points, 3 for Jackie. Pretty good. Okay, I need to introduce a new notation. So this is not a new concept, it's just notation. Another way to write this is to do this. Okay? So that you just memorize. No different than long ago, someone drew this. You memorize that that's A. There's no reason it's A other than they told you.
So that line stands for displacement.
No.
Like
The line stands for subtraction.
Oh.
Because it means this. It means take 2, plug it into x, subtract 0 plugged into x.
Oh, okay.
I don't know. Never used one.
So what does
Doesn't mean
that, what does that bar do on when you do math 8?
Oh, on Math 8, the bar is slightly different, but similar. So on Math 8, you're doing this.
So at this point in time now, the only way we can move this one down to back.
And now it means put into t, like take the derivative first, then plug into t6.
But what if you put up a t equals 4 on the top?
I've never seen that. I don't know what the heck that would mean. 2 points. 2 for Grant. It doesn't mean it's not legal. I've just never seen it used that way.
Yeah. Should it?
So it may be something I'm just not familiar with. Everybody good here? Cool. Okay, look. This is back to Gil's question. This is the fundamental theorem of calculus as it applies to position. But this theorem applies to anything. So generically, you can write this. Oops, wrong button. You can write 0 to 2, f prime. Questions about that? All I did is say if this applies to x and x prime, it has to apply to f and f prime. So, applies to anything. Good? Okay, the fundamental theorem suggests that there's a way to solve an integral without your calculator. Someone raise your hand and tell me, how in English words are f and f prime related?
Both of them find
Oh no, simpler.
Oh.
Just say f prime is the blank of f.
f prime is the derivative of
Perfect. Now say f is the blank of f prime.
f is the antiderivative of f prime.
Anybody have a question? So look here. If I'm trying to find the value of this integral, all I have to do is find out. F is simply the antiderivative of f prime. And then I just plug in the numbers and subtract. So that's how you solve the integral.
Just say that one more time.
The fundamental theorem says, if you want to find the value of this integral, one way to do it is to find the antiderivative of this. Here it is. Plug into that antiderivative 2 and 0. So we've just discovered, or learned is a better word, a way to find the value of an integral without a calculator. And this method is perfect. The calculator is an approximation because you're assuming that dx is really, really small. But on the calculator, it's small, but not infinitely small. We're ignoring that completely. We're just like bypassing it.
We're basically using infinitely small.
Basically, we are using dx being infinitely small. Question? So you have a flashcard. You need to add something to that flashcard. The flashcard says, why are we integrating? Well, we've learned all these different reasons why. And then the flashcard says, I got to know how to compute the integral. Sometimes they'll say do a Riemann sum. Sometimes you're allowed to use your calculator. Today we are learning that we can also use the fundamental theorem and an antiderivative, basically. We're really just using the fundamental theorem. I just put on anti to remind you that's how we're doing it. So. Question? Chance for people to write that down.
Here I have a difference, and when I write right here, as x squared minus square root of 2 squared.
Still writing?
Now I have a difference squared. I have a difference of squared. I go equal
Okay.
x1, x
So back to here.
and then I just put
So what we have to do to compute this integral is we've got to find the antiderivative first. Okay? So that's the same as plus, finding antiderivatives. Can I erase this?
Yeah.
So let's find the antiderivative first. Well, that doesn't fit anything on the pink sheet, so I think U substitution. For U substitution to work, I've got to have two things being multiplied. So my first thought was this. Let's see. 0 to 2.
Did you still put the limits on it if you just find the antiderivative?
Notationally, I want you to keep the limits on it. It works better. It's like less chance of error.
Okay.
Yeah, I'll kind of, it actually works really nice, Jackie. I'll just follow my notation, and it's super easy. It's just a matter of how you think about it. So you start off thinking, hey, I need to find this antiderivative.
So you kind of keep the limits there so you don't forget about them.
Correct.
Use them.
Correct. Does that make sense?
Yeah.
Perfect. So I thought of this. Two things being multiplied. Okay, I'm going to have you think with me, not just listen. Questions so far? Okay, when you have two things multiplying, you have to identify what form does each of the functions take. Keywords here, I'm going to use the word function and the word something. They mean related but different things. So I have two functions. Hands up. What is the form of the first function? Remember, you're trying to pick from one of these five. Something to a number, 1 over the something, e to the something, sine or cosine of something, but it's not sine or cosine here. So come on, think with me. Talk if you want, but think with me. This first of the two multiplying functions, which of those forms is the first function? And you guys know, come on. Jared.
Power.
Something to a number. How many knew it? 0.2 for Jared. So just say it out loud, please. What's the something? Say it. X. No, not x squared.
Oh, yeah.
No worries. X squared is the function. You're fine. X squared is the function, but the something is x. You understand? We need me to do it again. Okay, if I say u equals x, good or bad? Bad, doesn't help. So don't do that. So I move on to the next. Hands up. What form is this function of those three? Right here. What form is that? Morgan?
The 1 over something and then the e to the something.
Perfect. No, it's perfect. 1 over something. How many knew it? 0.2 for Morgan. So the something is, say it again, Morgan, what's the something?
The something is the e to the x cubed.
Perfect. So I write that down. U equals e to the x cubed. Come on, Pen.
Mr. Smith?
Yes.
So, I'm sorry, but why is having u equal x squared bad?
Oh, no.
Or u equal x? Why is that not happening?
Good. Because you can write this problem with all t's instead of x's. Do you agree?
Yeah.
You could put z instead of all x's.
Yeah.
You could also put u instead of all x's.
Okay.
And the problem wouldn't be any different. So if all I do is substitute u for x, I'm not helping.
All right.
2 points. Is that good?
Yes.
Okay. Next step is to take the derivative of both sides. Make sure, if this says dx, I have to put a dx here. Which means I'm taking the derivative in terms of x. So let's see, the derivative of e to the x cubed is e to the x cubed multiplied by the derivative of x cubed, which is 3x squared.
But you don't want that.
That's not very helpful because, back to here, I have two multiplying functions. If I use this one to pick u, we know that doesn't help because u would equal x. If I use this one to pick u, the derivative of the something is supposed to be this.
So would you do the x cubed? U equals x cubed.
So that didn't work.
So nothing.
Not the whole thing didn't work. Here's my suggestion, although your suggestion will work.
Okay.
And it's not worse or better, just different. Let's do this instead. So I still have two functions being multiplied. But by changing how the problem looks, I change my choice of u. So please talk and then raise your hand. What am I going to pick as u this time? That didn't work. Come on, talk, get your hands up. What am I going to pick as u now? Connor?
Negative x cubed.
This is a function of the form e to the something. As they say in the movie, u is always something special. So this helps, I promise.
Unless you have two e functions being multiplied together, you never want to choose the e function. As
The honest answer is it will just depend. So I can't give a rule for that.
most of the time when you take the derivative, you'll end up with e to this something. And so if you don't have that as the second factor, then that's not helpful.
You are right. What I'm anticipating is some problems that I can picture in my head that aren't on your sheet, but I've
Yeah.
seen them before, where the two functions both contain an e.
Yeah. So unless they both contain e, you don't want to choose the.
The whole idea is you are trying to see that you have two multiplying functions.
Okay.
You need to pick a u so that the derivative of the u is the other function.
Okay.
That's the whole idea. Does that help?
Yeah.
2 points.
Why is it the derivative?
The reason it's the derivative is it's the chain rule backwards. When you use the chain rule, the last thing you do is take the derivative of the something. That's what we're doing here. The derivative of this something, this is not the best answer in the world, Dan, but it's probably as good as I can give you right now. The derivative of this something is negative 3x squared, which does match this, except that this is 1 and this is negative 3, which we don't care about. It's that taking the derivative of the something that we're trying to figure out. Because when we took the derivative to start with, that's what we did, and that's what created this. And we're trying to work backwards.
Okay.
2 points. That's a long answer. The shorter answer is what I was telling Jackie. Just notice you have two multiplying functions. Identify the two. Identify what form they have. And then pay attention to the something. If you'll do that, pick u based on the something, it'll work. 2 points for Dan. Other questions? Okay, key thing, if you can get the right pick, like you can get to here, and you do the test and it works, the rest of it is just like a recipe. Okay? Here we are solving the problem. Here we are figuring out what replacements should we make. Like what substitutions do we make? We're just using the equal sign. So one replacement, where I see negative x cubed, I'm going to put u. Come back over here. I like to do the replacement first, so that's e to the u. And I have x squared dx. So don't just listen, make sure you're thinking. I need something that can be put in place of x squared dx. So talk and raise your hand.
You go.
What allows us to, where before we did, what allows us to just
We didn't ignore it. What happened was we tried this as our u substitution, and the test
du
failed.
over the x by
So he said, well,
negative 1/3, and then you
the formula sheet doesn't work. That's not an option. I don't have any other options. It's got to work somehow. It says they wouldn't have given me the problem otherwise. So I had to think of something else. So my thought was, well, maybe we want to do this as a numerator. Looks different, same problem. They didn't have it. That's all. It's kind of a guess.
now is the something what's parentheses always x or
No, it could be sine or cosine. That's just whatever. E to the something.
But once you dx of whatever that is of u, it has to equal the
the other multiplying function.
Now, if there isn't another multiplying function, then there's usually
Yes, or the other multiplying function will be a constant, and the derivative of your u will be a constant. And so it will be a constant.
if the constant is 2, then
Yeah, then we'd want this derivative to be 2. Or any constant works. There's more to say. Hands up, come on. What am I going to put in place of x squared dx? Hands, come on. What am I going to put in place of x squared dx?
du over -3.
So I multiply the dx across. And then I move the -3 over here. I prefer multiplication to division, but whatever. How many knew that? 2 points, 3 for each. We want to talk about it? That's just algebra. I multiply both sides by dx. I multiply both sides by -1/3. But the thing to notice is the equal sign. Equal means the same. That's really bad. Alignment there. So wherever you see this, you can put this in place. So over here, I'm going to do that. I have to put parentheses, otherwise it looks like I'm subtracting when I'm multiplying. So, questions? Yeah, please.
So you replaced, instead of using -1/3, you used -1/3 dx.
Oh, that was a mistake.
Is that just,
Hold on, 2 points for Ethan.
but either way, it doesn't
No, it has to be
really
a
change
U.
it?
Oh no, it has to be U.
It does, but they're both just part of the function, like they don't have any numeric value, right?
The difference is we start the problem where the variable is x. We don't have it. It's just whatever. But once we introduce u, we cannot loosely treat u. U has to follow this rule. So so I have to put du. 2 points. So that's why we don't do w substitution, because then no one laughs. If people laugh when you do u substitution. So. Apparently my big mistake yesterday became somewhat viral. I don't know, like in B7 yesterday, I said this is kind of like black magic, like sorcery.
Sorcery.
And they're like, everyone just laughed and laughed. Like, why are you laughing? Like, no one's just sorcery. Never mind. Okay. Du means infinitesimal difference in u.
Oh, so it's the same as that.
But u and x are different.
It's
So-
a different meaning, but in respect to different.
In respect to each other, they are not identical. Like as far as the meaning is identical, but their value is different. Look up. Questions to hear. So -1/3 is a multiplying constant factor. So pull it out.
Still have to draw the integral, or can you jump to the next step?
I still have to draw the integral because we haven't resolved it yet.
Well, can you just jump to the next step, or do you fine?
Not in this case because there's one more thing that's new.
Ah, heck.
Ah, heck.
Okay, I can put first that step and just go to the next.
Yes. Actually, Nicolette, it's the same thing I told you with derivatives. As you get better and better, you can skip as many as you want. Yeah, there's no rule as to how many you have to write. I just don't want anyone
So
to get
eventually I
lost.
can skip that one.
No. It's,
fine.
oh heck. Because we got to learn the new rule. The new, it's not a rule, it's a new idea. Okay. Hey, anybody need more talking to here? Going like this is very helpful, thank you. Okay.
I'm still a little confused on why you did the 0 to 2.
Oh, 0 to 2 is a random example because I'm trying to teach you how to do a problem like this one, which is what, there are many of these on the pink sheet.
Does that like, I mean,
Yes, it just hasn't yet. Fair? Like so far we've ignored the 0 and the 2. Yeah, so far it has not affected the problem at all. It will. But I chose this one due to the questions you all were asking me. Like several people said, I'm having trouble with E. So I picked one that had E, but I didn't have limits, and I need to have limits. Okay. So, okay, look. I need to copy this page. Is that be good? So I'm going to make a copy. Just takes the computer a moment. Hold on. Wait for the 5 to appear. There we go. Okay, at this moment, it is very important that you understand the difference between finding an antiderivative and finding an integral. You have to understand the difference now. So far, there has been no difference. But this is the moment where the two pathways split. Let me move this. And you need to keep asking me until you are very comfortable, because again, we are talking about ideas that are hugely tested, more than anything else on the entire test. If I were going to continue and find the antiderivative, I would ignore the 0 and 2, just completely. And I would say the antiderivative e to the u is just e to the u. And then I would substitute in for u my choice of x. My choice of u. Like that, and I would be done. So the answer to problem 3 on the homework is this. Is that not one of the multiple choice answers?
I'm sure it is.
Yeah. The negative
3.
Or we solving our slightly different problems because it shows a difference.
Yes, so stay with me. So what I'm saying is, if we were actually solving number 3, this is the answer to number 3. Because number 3 on your, not the buff sheet, the pink sheet.
I thought we
Keep going.
were solving for the. I thought we were doing an example where we were multiplying x squared and e to the x cubed instead.
Oh, what you're remembering is that we rewrote this. I think. Don't stop asking, Bree, until this makes sense. Are you saying we were doing this problem? Is that what you meant?
Yeah.
We were, but they're the same problem. Because math, are you with me?
Yeah.
Okay, 2 points. No worries. Oh, you didn't see the negative.
Yeah.
Gotcha, so it felt like a different problem. I got you. Please, say.
None of the answers have negative points.
They wrote it like this. Right? Those are the same things. Please.
On the AP test, if you have a negative exponent, will they mark that wrong if you don't bring it down?
You are correct. FRQ section, you can stop here. It's totally fine. Multiple choice. You don't get to, I'm going to use that phrase. I like that a lot. You don't get to make up your answer. So you've got to find theirs. So, yep. Anybody else? Okay. Come on, look at me. Look at me. Like, you just cannot get lost here. This is what we would have done to solve number 3 as written on the pink. Good? Okay, we got to back up, so I'm going to erase all the blue.
So what happened to the du though? I mean, it's just
My answer to that is not mathematical. It's more like, okay, is this good enough for now, and this is the best I can do for now. We just don't get into the details. If I write this, what do you write here? And then I can be very cynical and say, I'm not trying to be mean, I'm just trying to make a point. What happened to this thing? The radical? Like, where'd it go? It was resolved. We did what the radical told us to do. Fair? Okay, over here, this symbol combined with this symbol are like the radical. They're telling you, find the antiderivative. Once you have found the antiderivative, they disappear. Right. Okay, look. Look up, come on. Hey, look at me, come on, you cannot get mixed up here. Look at me, you cannot get mixed up here. This is how we solve number 3. But we are doing number 3 as though it is an integral instead of an antiderivative to help all you with this whole e thing. So I'm going to erase all this because we are not doing the antiderivative. We're doing the integral. When we're doing an integral, here's what changes. We don't go back to x. We stay with u. We do not abandon you. We stay with you.
No toys left behind.
Okay? Got it?
We abandoned.
Look at me. Come on. Okay. We are making a transformation. We started with this problem. We are transforming it to an easier problem to be solved using u instead of x. Okay? This problem still has some x's. We have to get rid of all the x's. Does anyone know what x's I'm referring to?
Wait, the limits.
The limits.
Really?
Oh. That's totally what I
Nice.
That's exactly what I was going to say.
Look. Hey. This is x equals 0 all the way to x equal 2. Okay? We are changing everything from x to u.
So would you plug in x into what u is, and so then you write down what u equals at that x?
Yep.
What?
Wait, but it's at both of them.
Look up. Look up.
So you have to find like u of
Yeah.
0 and u of
There you
2.
go. So we plug into
of
u.
0.
Well, I'm not going to write that, but it's the same idea.
Yeah.
So I say u equals negative 2 cubed negative 8. U equals negative 0 cubed 0. So now the transformation is complete.
Then you write negative 1/3 z.
Where are you getting the negative x cubed from?
Remember that that was our choice for u.
Oh, that's right.
Our choice for you was this.
Sounds like some
It's like a backwards view sound.
It does sound like the old Abbott and Costello, who's on first. That's a really good one.
Okay.
Yeah, that's outstanding, actually.
You
Please.
still put you put the smaller number on top because that's the x value that coordinates with it, even though it's smaller.
Yes. Hold on. Listen to what Jackie said. I keep telling you over and over again, it's all about the equal sign. Like you gotta follow the equal sign. Right here, you plugged into this formula 2. The result was negative 8. That means when x is 2, u is negative 8. I know it sounds awful. 2, u is negative 8. U is something special. Okay. You good? Please.
Wait, why did we do that?
Because once it's an integral, now I have to be honest with you, there are more than one way to solve this problem. I am showing you the way that will get you the most points on the AP test, I guarantee you.
Mr. Smith, Harrison G is being checked out.
Okay. So the method is when it's a integral involving u substitution, we change everything to u and don't go back. We stay with u. We will not abandon you. We will not leave you alone. Okay? Nazi, is that okay?
Wait,
Keep going.
why do we do like, what is it, like the 0 and negative 8, like why do we do that?
Because they were values of x.
Okay.
And I need everything to be u.
Okay.
Good work. 2 points. Please, that.
Do you have to write like equals for the limits?
No, I'm just, the grader knows, I'm just making sure you know. Yep.
Every time going.
Please.
So you said we just chose you as the variable they also choose
The AP test, I've never seen them choose anything but. So it seems safe to me. They get tricky and choose W, don't stress, just oh, same thing. Yes, we got 4 minutes. Look up. Look up. Sorry. Same. Oh, watch. Silence. Look. Okay, remember the big idea. We are solving two big ideas. One, we did this massive transformation. We had this problem to begin with, now we have this one. The result is identical. You type this in your calculator, you type this in your calculator, exact same result. Because we've used the equal sign. Right? Like everything we did was equal. So this in your calculator, exact same result. Okay? But this one is now easier. That's why we transformed it. Okay? If we had more powerful brains, we could have just figured it out from here. But we don't.
We're not as smart as a calculator.
So, well, you're way smarter than a calculator. A calculator is just a dumb piece of silicon. Okay.
But I give you that.
Look, only because a man figured out, mankind, womankind, okay, no genders for you.
Oh.
I did not want to be biased. It's true. You understand, right? Okay, good. I don't have any bias.
I don't either.
Look, stop talking.
Sorry.
Listen. Okay, remember the fundamental theorem. It says this integral is equal to the antiderivative of that with the limits plugged in. So the next line you write, -1/3. Now this one seems a little weird because of the antiderivative, but don't lose track. You're finding the antiderivative. What is the antiderivative of e to the u? E to the u. Bar, 0 to -8.
That's where it comes from. Oh my God.
It's the Wilson.
It's the Wilson. In first period, I said bar. Nick Wilson said, "Can we name it after me?" I'm like, why not? I don't care. One year they wanted to name it Frank, so whatever.
So then you would plug in those two in for you and subtract them.
Yep.
So you don't have to do like 1/3.
Oh, because the
never
1/3
mind.
would distribute it anyway. Yeah, you can see. It's just factored out.
It
You're fine.
works.
Questions? Please.
Why does the EU go there?
So it's the fundamental theorem we talked about at the beginning, that when you are integrating, the example I gave you was 0 to 2. I said if you're integrating f prime,
Well, there is.
the fundamental theorem says this is equivalent to the antiderivative of f prime, which is f, with 0 and 2 plugged in, and then subtracted. What looks funny, Hadley, is the antiderivative of e to the u is just e to the u. So it looks like we just threw stuff away, but we did not.
Okay. And then you would, like, if it's multiple choice, you would solve.
You must find their answer, right?
What's?
We're going to stop here because that's
Because
good
we don't
enough.
have.
Because you don't have a
But
multiple.
you would find e to the -8 and e to 0.
Questions?
You can't make them wrong.
Should we stop at the one before that?
No, because there's a calculus step still remaining. The calculus step is, like you just learned this in calculus. So you've got to prove to the grader that you know what that means. When all that's left is add, subtract, multiply, and divide, you can stop. That's why I can stop here.
But doesn't that just like mean the same thing?
It does, but they're still testing you to see if you know the calculus symbol. Does that make sense?
Yeah.
Yeah. If you stop here, you do lose it. Okay. Say how.
So all the answers are going to look like that?
No way.
That's
It works. For multiple choice, they'll probably put a 1 right there. Because e to the 0 is 1.
So if you see an answer with anything other than add, subtract, multiply, divide, it's wrong, no matter what.
No, you're misunderstanding. On a multiple choice test, you have to do what Jackie said. You don't get to pick. You have to find the answer. Okay, but on FRQ, you stop as soon as all that remains is multiplying, adding, dividing, subtracting. That was the ring. Are we okay? Sure. There are 5 videos now to help you with the homework. That's a third of the homework.